Hi, Mark.
Hey, David.
How are you?
Good.
Good. All right, shall we pick up where we left off on Tuesday with the second page?
Well,
Or do you have new stuff you want to do?
not quite, but I have a quiz tomorrow and just finding surface area of cylinders and cones and all that kind of stuff, and I was just hoping we could go over that stuff.
Okay. Well, that's what these questions are the surface area of a rectangular prism, the surface area of a triangular prism, surface area of a pentagonal prism, right cylinder, right cylinder, right cylinder, right cylinder.
All right.
Is this page okay?
Yeah, sounds fun.
All right. We did number 6. I don't think you have any problem with a rectangular solid.
No, I don't.
7 is a little trickier. Notice that on 7, everything is rectangular except the triangular part there and the triangular part there, and that's what makes this a prism, is that I have two opposite and equal and parallel triangles. So we're going to treat this kind of like a rectangular brick, only we got to figure out the triangles separately. Now,
Okay.
one of the keys is they give you a hash mark there and a hash mark there. That tells you that that triangle is isosceles. Okay?
All right.
So, if I wanted the volume, is that going to be on your quiz also? Volumes or just surface areas?
Just surface area.
Okay. So, surface area, I've got to figure out the area of every face that I can see and just add it all together, right?
All right.
So, let's start with the triangle. It's the hardest one. What's the general formula for the triangle? Area?
A equals 1/2 BH.
Okay. Well, we know what B is, right? B is 3.
Yeah.
How do we figure H on this triangle? Remember, H is always vertical height.
We could use the Pythagorean Theorem.
Okay. So let's bring this triangle out, analyze it. In other words, just 1/2 of that triangle. We know that side's 8. What's the bottom dimension?
1/2.
1 and 1/2. 3 halves. And the reason is that when you start with an isosceles triangle and you drop a vertical, that vertical bisects the base.
Okay.
Okay? So this base has to be half of 3, or 3 divided by 2. Now, that represents H. How do I get H? What's H equal to? Remember I told you we're going to have to do this 100 times? Well, this is...
H is...
What's the general?
Square
root of what?
Isn't it 8 squared plus 3 halves squared?
Minus 3 halves squared.
Oh, yeah, because it's the hypotenuse.
Well, because we're solving for one of the short sides. Whenever you're solving for one of the short sides, you need to have subtraction going on inside the radical. If I was solving for the hypotenuse, and perhaps I confused you a little bit here by using the letter H, That's not the hypotenuse. That's a short side. And so we have to do this. Okay. So h would be the square root of 64 minus 9/4, which is the square root of 61.75. Do you have a calculator?
Not on right now.
Hold on. So control square root of 61.75 should be 7 something. 7.86, round it off. So now, tell me what the area of this triangle is. The one I circled. Plug it into the general formula.
Wasn't it just 7.86 times 2 for the whole triangle?
Well, let's plug in to that general formula. That general formula is what applies to this big triangle here.
Oh, yeah.
What's the base?
Still 3.
Aha, but it's not 3 halves. In other words, I split it in half in order to solve for h. But the base is still 3, and h is 7.86. So the area of that thing, come up with a number for it. I have to multiply that by 1.5. Oops. Multiply by 1.5, enter 11.79. That is the area of one base of that prism.
Okay.
Now, what's the total area of that object, that surface?
For both of the triangles or just
one? We got the area of one triangle.
Yeah.
Equals 11.79.
Okay.
Go from there. What's the total surface area of this object?
Well, we have to multiply that by 2 to get both sides of that.
Okay. It's a good starting spot. Hold on. Times 2 equals 23.54. And you can see, or 0.57, you can see already I'm getting some accumulated round-off error. In other words, notice how I got this. I figured out h, but I rounded it off first. Then I multiplied it by 1.5. Then I multiplied it by 2. I know I should not have rounded off until I got to the end. So you're doing this on your calculator. Don't round off early. This is a good lesson. Because when you round off early and then you multiply it by other numbers, it changes the round off. Okay, I don't want to go back and waste more time doing this, but this is the area of the two triangles. What else do we have?
All right. We could also account for the I guess you could call it the base, is the,
Okay, how big is that?
well, the little rectangle that's height is
Well,
3 meters.
okay, so what's the dimensions on that?
It's 3 by 9.1.
Okay, so we'll call that 27.3. That's strictly
Okay.
the base of the suitcase, or whatever you want to call this object. I don't even like calling it a
Yeah.
base. You know, the reason I don't like calling it a base is because we're talking about a prism, and the base has a very specific definition on a prism. So let's call it the bottom.
Okay.
What other surfaces? How many of those are there?
Just one.
Okay. What other surfaces?
We have
Call it a
9.1.
rectangle, since I don't know
Yeah.
what else to call it. What's the area of that rectangle?
9.1 by 8 times 2 is for both of them.
Okay, so that's 72.8 times 2 equals 145.6. And that's it. So we want to add together the area of the two triangles plus the area of the bottom plus the area of the sides. We'll call that sides. I don't know that there's an official name for that. Just be careful about calling it a base. I mean, in other words, you could make an argument why you would call that bottom the base because it's sitting on it. Okay, so the sum of these three numbers is your answer, but just to warn you, we're liable to be off because I rounded early. If you do this problem again on your own, make sure that when you get to this step here, you do not round that off until you're done.
Okay.
And to be safe, I mean, you don't need to carry it to 6 decimal places, but to be safe, carry it to 4. If I make h to 4 decimal places, then I can get away with rounding it off early. I mean, I'm going to multiply it by 1.5, and then I'm going to multiply it by 2, but even still, if it's to 4 decimal places, I'll be all right. Okay, so if you must round off early, round off to more decimal places than the answer requires.
Okay.
All right, number 8. I think it's important that we cover at least 7 and 8 because every other thing here is a right cylinder. We covered right cylinders on Tuesday, and we'll have time to do at least one right cylinder problem, but these are harder.
What about cones and stuff?
Well, cones, yeah. Just a second. All right, before we go any further, let's look at cones. Cones are special. The surface area equals the area of one base, which is a circle, plus pi r lambda. And this is what's different about cones, where lambda is this side length. It's not a vertical length. Okay. The area of the base is clearly pi r squared. There's only one base. But the surface area is pi r lambda. So you need this lateral measurement. Okay. And that's the only thing really kind of different about all these objects. Most of them follow, you just add up the areas of all of their faces. But it's difficult to get the area of that lateral face of a cone. In other words, if that was a piece of paper and I cut it apart and laid it out flat, it wouldn't be a rectangle. It would be tough to figure out the area. So they give you a special formula, and that's it. And remember, and the base is pi r squared. So if you can just remember that and use lambda instead of L, because lambda means lateral length. It's not a vertical measurement. So cones are a little different. But so is this object here. Prism or not? Number 8.
I think it is.
Yeah, I've got a regular pentagon there. I got on the back side a regular pentagon. They're parallel, they're equal, they're opposite. So, for the volume, it would be the area of the pentagon times the thickness of the thing, right? In other words, volume is always the area of one, for prisms, the area of one base times the thickness. In this case, the thickness is 3.5 inches. But again, sounds like you're more interested in surface area. Well, each of these lateral faces on number 8 is going to be easy, correct?
Yeah.
They're each 2 by 3.5. And there's 5 of them. So the only thing that's really going to be tough is the area of the pentagon itself. What's the general formula for the area of a regular polygon?
A equals ASM.
1/2 ASM. Okay. With A being the apothem. And the reason this is relatively tough is they don't give us the apothem. They give us that. That's it. 2. So again, we have to work with the triangles. The fact that it's a pentagon means I can put 5 triangles in there. Well, we have to figure out one of those triangles to figure out the apothem. So there's one of the 5 triangles. I've just enlarged it a little bit. Again, the apothem is that vertical height right there. And again, that's an equilateral triangle because it's a regular polygon. So if I pull out just one, I'm going to have this triangle. This side's going to be 1 because this apothem bisects the base. Okay, but we don't know any other dimensions here. So we're going to have to use some trig, and we're going to have to figure out what that angle is. Well, let's go back to our regular pentagon and figure out what the central angle is. What's the central angle on a regular pentagon?
1/5 of 360.
Good. 360 divided by 5 equals 72. So that angle at the top is 72. Now let's go to our triangle over here that we're trying to solve for the apothem. What's this angle right here?
46.
36. Is that what you said?
Yeah.
Okay. Now, notice we can solve that triangle. In other words, the only thing we know the side lengths is 2. We know the number of sides is 5. So the only thing we need is A, the apothem. And we're going to get it from this triangle.
Okay.
What trig function do I need to use? And what equation? Give me an equation that lets me solve for A given this.
Tangent 36, 1 over A.
Therefore, A must be what?
Would it be 30s?
Well, it'll be 1 over tan of 36. In other words, whenever you have an equation like this, you can multiply both sides by A and divide both sides by tan of 36 to turn it into solving for A. Or you can just flip it. In other words, there's a couple of ways to do this. The easiest way is to just flip both sides. When I flip the right side, I get A over 1. When I flip the left side, I get 1 over tan of 36. And always think about these things as numbers. Even though we don't know what number it is, we know it's a number. And I can get that out of my calculator. I will. So I've got 1 divided by the tan of 36. Enter. Control Enter. 1.38 rounded off. Now I'm going to round it off to 4 decimal places. 1.3764. The reason I'm doing that is the answer calls for rounding it off to 2 decimal places, but I've got to take this apothem, I got to multiply it by 2, I got to multiply it by 5, I got to divide the whole thing by 2. So if I round it off early, I'm definitely going to induce round-off error and end up with the wrong answer. So I'll use rounded off to 4 decimals. So the area is 1/2, the apothem, 1.3764, multiplied by the side length, which is 2, multiplied by the number of sides, which is 5. 2 cancels at that 2. And I want to basically take this answer and multiply it by 5.
Okay.
Now I can, now I can round it off. And multiplying this by 5 gives me 6.88, rounded off to 2 decimal places. And even that I can't really round off yet, because I have to multiply that by 2. I have this front pentagon and I have the back pentagon. So I have to actually, that's the area of 1 pentagon. So I really kind of need to multiply it by 2. Well, we'll see if that matters. In this case, it doesn't matter, because what I got was 6.8819. And now, if I multiply that by 2, I get 13.76. That is the area of 2 pentagons.
Okay.
Okay. And I can round that off early, because to figure out the surface area of this thing, I've got to just add what?
Mm, all the other sides left?
All the lateral sides. What's the area of each lateral side?
That was 7.
How many sides are there?
5.
So 35. Now that's why I don't care that I rounded off early, because I knew that was going to come out to be a whole number. If that's going to come out to be fractional, then I don't want to round off early even here. It's safest to never round off until you get to the end. But in the case where I'm going to be adding a whole number, an integer, it's okay. It's not going to affect anything. So my answer is 48.76. That's the total surface area of that object. Notice that it's quite a bit tougher to figure out surface area than it is to figure out volume. For volume, I would have merely had to figure out the area of one end and multiplied it by 3.5, and that's my volume. As opposed to surface area, where I still had to figure out the area of one end, then I got to multiply it by 2 because there's 2 ends, and then I got to figure out the area of each of these panes and multiply it by 5, and then add everything together. So surface area is tougher than volume. Now, since you mentioned cone, let me do one real quick cone. I don't see a cone question on there, so I'll make one up. We have just a brief moment. The secret on all of these is the general formula. What is the surface area? And I like to use SA to call surface area. What's the general formula that I said?
Is that 1/2?
No, this is not a regular polygon. This is a cone. So start with the base. The base is a circle.
Base times height?
No, not with a cone. If we were talking volume, yes. If we were talking surface area, the thing that's important is this lateral length. But first of all, we have the base. What's the area of the base?
3.
Pi r squared.
Yeah.
That's 9 pi. R is 3. Okay?
Yeah.
Plus, what's the rest of it? In other words, here, I'm going to write the general, because if you need to memorize the general. If you can memorize the general formula in all of these problems, you'll have no difficulty. But if you don't know the general formula, you got no shot. Okay? So the general formula is the area of the base plus what? And this is the strange one.
Area of the base plus the side length?
Right. Pi r times the side length. So now we just fill in everything. Well, r is 3, so that's 9 pi. Pi times 3 times 4, that's 12 pi, so our total is 21 pi. It really becomes a piece of cake if you can memorize those. So if you have a quiz tomorrow and you got to memorize stuff, make sure you understand the general formula for the surface area of all of these objects.
All right.
Okay? And this is the hardest one to memorize because it's different. It's the only one that depends on a lateral length. All your other surface areas, you're talking apothems, you're talking things like that. But this is the only one that uses lambda. This L over here. So make sure you memorize this one for sure.
Okay.
All right, Mark. You have a good weekend, and I will talk to you next Tuesday.
You too, Dave.